Let's remind ourselves of the distinction between x plus y squared and x times y squared. Let's first expand out x plus y squared. Remember, a squared for any number a is equal to just a times a. So x plus y squared, x plus y is just any other number, so this is just going to be x plus y times x plus y. And this guy is a product of two binomials. So when we expand this out even further, we can just use FOIL to give us x squared plus x times y plus another x times y plus y squared. In combining like terms, this gives us x squared plus 2xy plus y squared. So this guy is what we get when we expand out x plus y quantity squared. Let's look at what we get when we expand out x times y squared. Well, again, we can think of this x times y as just our a, so this is just going to be x times y times x times y. And remember, if I were to multiply like 2 times 3 times 4, it wouldn't matter if I first multiplied 3 times 4 together and then multiplied that product times 2, or if I multiplied first 2 times 3 together, then multiply that product times 4. No matter what, I'm going to get 24. And also, remember, it also doesn't matter if I do 4 times 3 times 2. I'm still going to get the same thing as if I were to go, say, 3 times 2 times 4. So the order in which I multiply things doesn't matter, and the way I group the things I'm multiplying doesn't matter. And since the only operation going on here is multiplication, I can just drop parentheses. I can drop parentheses and I can rearrange however I like. So let's rearrange cleverly to use this fact. So if I rearrange cleverly to use that fact, then I just get x times y, which is equal to x squared times y squared. And again, remember, if there were plus or minus or other operations going on here, we'd have to be a little bit more careful with our order of operations. We'd have to be a little bit more mindful of the order of operations and how we're abiding by the order of operations. But here, since the only operation going on here is multiplication, we can drop parentheses and we can rearrange however we'd like. So x times y squared is equal to x squared times y squared, and actually in general, x times y raised to any power a. A can be any number. This is equal to x to the a times y to the a. But this is not necessarily true over here. If we did x plus y to any exponent a, this is not necessarily equal to x to the a plus y to the a. For instance, if I had an integer here, let's say that this was 17. Let's say I wanted to expand out x plus y to the 17th power. This is equal to x plus y times x plus y times x plus y 17 different times. 17 times. And we would have to FOIL each of these. We would have to, or you could use the binomial theorem. Check out our video on the binomial theorem. But this guy does not necessarily simplify to this guy right here. Maybe if x and y were both 0, or if x and y were both 0, that would certainly be true, because 0 plus 0 plus 0 to the a's power is equal to 0 to the a's power, which is equal to 0, and then 0 to the a power plus 0 to the a power is certainly equal to 0 plus 0, which is also equal to 0. So if x and y were both 0, then sure, this would hold true. But in general, in fact, in most cases, this does not hold true. This non-inequality is true. That is, x plus y to the a power is almost never equal to x to the a plus y to the a.